Right, so we're going to carry on and we're going to start talking about valves of the heart. So that's going to be the next little subsection of this topic. So valves of the heart. And the first thing is just a kind of little bit of introduction, I suppose, to what valves are and why we need them. For some of you, it might be perfectly obvious why we need valves, but I bet there'll be some people who are listening to the lecture and thinking, I don't really understand, I heard the word, but I don't really get it, you know, what this valves thing is all about. So, valve, what does it do, first of all? Not just in the heart, but in any system.
Open and closes.
To do what? Well, why does it need to open and close? What does that achieve?
It stops things travelling.
Okay, but why do you need to...
So you can control it.
Right, okay. So you have to have control over the flow. But what are you trying to do by closing it at certain times?
Create pressure.
I mean, I can create pressure by squeezing the heart. That doesn't need necessarily valve. But valve...
But if you close the valve and there's a consistent inlet of stuff, pressure not build, and then that helps with...
Right, okay. So you're sort of giving me correct answers in a sort of a roundabout way. So can I give you just definition and then we're going to discuss it, okay? So the purpose of any valve, and it's not just in the heart but in any system, like in your boiler, in your aquarium pump, whatever pump you have, you will always have a system of valves, at least one or maybe more than one. So the essence of why you need a valve is that they prevent the backflow of liquid. So I'm going to write it down, then I'm going to kind of do some a little bit of explanation around it. So prevents backflow of liquid. Obviously, in this particular case, this is like a very, very general statement. In this case, the liquid is going to be what? Blood, right? So in that particular case, our liquid is blood. But as I said, that can apply to any liquid. Right, so let's think about why you need valve. And as I said, for some people it might be super obvious and they don't need that bit of explanation, they want to skip it, that's fine. But if you're a bit sort of unsure, here's a little diagram. Now imagine if I have a rubber tube, and inside this rubber tube I have some liquid. Let's just say water, right? So I have a rubber tube with water. So if I squeeze the middle point of that rubber tube, like that, right? So imagine I have a tube and I'm squeezing it, right? Where would fluid want to go as I'm squeezing that rubber tube? What's going to be happening to the fluid on this side? Where would that want to go? In what direction? So it's filled with fluid, I'm giving it a squeeze. What's going to happen to this side? Right, Laura is like pointing that way, right, towards the window. What about liquid on this side, right? Can you all picture it in your head, right? Squeezing it, fluid will want to go in that direction. Now I'm going to let go, okay? Where is fluid wanting to go here, on this side?
It's going to spread out.
Right, when you say spread out, what do you mean spread out? You're sort of pointing it that way, right? So on this side, it'll want to go that way. Do we all agree? What about this side?
The opposite.
Yeah, the opposite way. Right, have I achieved anything? Has it overall moved anywhere at all compared to that picture? Compared to the starting point? Well, no, right, it just came back to where we started, right? So I gave it a squeeze, and all it's done is, and then I let go, and all it's done is that liquid came back to exact same position where it was before. So essentially, what I'm doing by squeezing, that I'm imitating action of a pump. Because that's what pump does. It sort of squeezes liquid, you know, and then lets go. Squeeze, let go. Squeeze, let go. So squeeze and let go doesn't really achieve anything. So I can be squeezing and letting go until, you know, dawn of time, and I'm not going to move that liquid in any particular direction overall. Hope that's clear, yeah? So we need something else. because that squeezing action doesn't actually achieve much. So now imagine I'm going to introduce a little gate inside that rubber tube, okay? And maybe I'll draw it in a different color so it stands out a bit. Use green maybe, okay? So I'm going to have a little gate here, and it's a kind of gate which can swing, okay? And can only swing in one direction, so it can swing that way, but it can't go in that direction, so that action is not allowed. So let's now consider. So I've got again, I'm going back to my tube, I'm going back to my liquid inside the tube, but now I have this gate as well. So this time I'm going to squeeze my tube again. Okay, I still have my gate here. Let's think, what's going to be happening to the liquid on this side? Where is that wanting to go? Towards the door or towards the window? Right? And where does this liquid want to go? Towards the window that way or towards the door that way? Towards the window. Right? So now, can you see that liquid is going to push on my gate, and that's going to swing and it's going to open. So let me draw that. Right? So you have to picture it in a bit of like a 3D motion, right? So that gate is going to swing because I'm pushing on it with my liquid, and that portion of liquid is going to get on the other side of the gate. Right, now I'm going to let go. So back to the same scenario. So I still have my gate. Right, where is liquid wanting to go on this side? I need a bit of help again from you. Am I again going it that way, pushing it that way or that way? So I've let go now. So that liquid moved there when I was squeezing. I'm now let go. It's going to go, Laura is again pointing, it's going to go that way. What about liquid which is here? Where is that wanting to go? Back this way. But can you see now, because it's pushing on my gate in the opposite direction, it can't actually get back where it's trying to get back to. Right? So by introducing this gate, what I'm doing is, every time I squeeze, a portion of fluid goes through and then can come back. Next time I squeeze, another portion of fluid goes through and can't come back. And so, you know, that then creates a continuous flow of liquid. So if I didn't have that swinging gate, if you like, right, I wouldn't be able to move liquid overall in any specific direction. Does that sort of make sense now, right? So my gate in that picture is the valve, right? So this is very, very simple valve. A lot of valves are a lot more complicated now, but it gives us a good idea of what valve does in this scenario. So let me just slightly different, right? So that green line is valve. Okay, so this is valve gate. Okay. So that just gives you kind of a little overview of why we need valves in the first place, right? Obviously your heart is a bit more complicated than just a single rubber tube. So you have more complicated system of valves, and they have a little bit more complicated, more sophisticated design than just a single swinging gate. Okay? Can I now wipe this off? Okay. You don't have to include this in your assignment, by the way. This is just to clarify what the term valve is and what it does. It doesn't become just a word which you sort of think, oh yeah, okay, but I don't really 100% understand what that means. Okay, perfect. So let's now talk more specifically about the heart. So what kind of valves we have in our heart and where do we find them? Right? So you have two types of valves. So two types of valves in your heart. And what I might be able to do is I'm going to just sort of group all the information about the first type of valve on this side of the board and the other side on this side. But you could just do it as a continuous list, up to you. Okay, it's just because the board sort of lends itself to that, doing it that way. So the first type of valve is called atrioventricular, a bit of a mouthful, I'm afraid, right? So they're called atrio. Right, because it's a bit of a mouthful, it's often abbreviated to AV valve or valves. So atrioventricular becomes AV. So you have two of those. So two of these type. Now let's now think about where you find these valves. Now the clue is in the name. So atrioventricular, where do you think you're going to find the valves? Where do you think they're going to be located? Between what and what?
Between the atrium and
And
the ventricle.
correct, right? And you have, because you have two sides of the heart, right? So two spaces between the atria and ventricles. Therefore, you have two valves. So if I do a very quick sketch right here, right? So remember that wall, the septum was solid wall, so no gaps. And I know in the past I just used kind of solid line here, but it's not really solid. I was just doing it for illustration purposes. So that line is not really, continuous line. It does have those gaps, right? So you have lots of these gates or valves, one on one side of the heart and the other is on the other side of the heart. So those openings, those gates, are my AV valves. Okay, so because I've got two sides and two valves, they actually have specific names in medicine. Terry, okay?
Yeah.
Okay.
I forget which way they are.
You can't remember. Do you know the names of these valves?
Bicuspid and tricuspid.
Yeah, exactly. So they're called bicuspid and tricuspid valve. So let's think, this side, is that left or right side? Very quickly. That is
That's the left.
left side, right? So let me maybe do it in a shall I do it in different color? Don't know. The problem is if I use blue and red, people instantly think it's something to do with deoxygenated blood. I might use this green then, like that. So left side, so this valve, but then I'm going to write in black, how about that? So left side, it's bicuspid. And on the right side, it's tricuspid. Okay. Now, bicuspid valve is also known as mitral valve, so I'm going to put it in brackets. So mitral. So you might come across that term in some books or websites. So bicuspid or mitral valve. Right, let's think about the term bicuspid, tricuspid. What does bi suggest? Two. What about tri?
Three.
Three, right? So like bicycle, tricycle, right? So in bicuspid valve, you have two cusps, and in bicuspid valve, in tricuspid valve, you have three cusps. So then the question is, what are cusps, right? So what are cusps? Didn't spell it right. Just a minute. Another try. Not quite cups of tea, but cusps. Cusps. So cusps are those flaps of tissue, like if you like those gates, right, which are used to open and close the valve. Okay, so they're very thin but very strong bits of connective tissue. So flaps of connective tissue that open So in a bicuspid valve, you would have sort of system of like two gates, yeah, opening and closing. And then in tricuspid valve, that's going to be a bit more difficult for me to show you, but it's basically like going to be three of them, right? So one there, and again they're doing that kind of motion. So they're flapping up and down to either open the valve and let the blood come through, or close it and then stop it from being able to backflow. Okay. So next, I wanted to give you a little bit of a engineering DIY challenge. Can we have a go at that? Okay. So here I've got my incredibly high-tech model of one side of a heart made out of Finnish box of dishwasher tablets. So I only made a model of one side of a heart because on the other side you'll have exactly the same. Is that okay? Can everybody see it? Okay. Right? So imagine the top bit is my atrium and the bottom bit is ventricle. Can you all picture that? And can you see my two flaps of tissue right there? Yeah? And those flaps of tissue are going to be my cusps. So imagine this is bicuspid valve because I have two of them, two flaps. Now, let's think about it together. So what I want for this valve to be able to do is I want it to be able to let the blood through from the top towards the bottom, from the atrium into ventricle. And then when I'm squeezing ventricle, I don't want it to come back towards atrium. So I want that valve to be closed. The issue is, at the moment, the way I've designed it, is that if I'm pushing on those flaps, it's letting liquid through. And if that liquid is pushing on those gates, can you see, they're open again. And they would be letting that blood coming back up towards atrium. And I don't want that. Right? So what I want is to figure out some kind of system which would allow those flaps to open down, but then when I'm pushing them, I want a system which stops them from going above 90-degree angle. Can you see that? So that's what I want. So here is my little bit of DIY engineering challenge. So if you had something like this, a gate at home, and you were thinking, right, I want it to only open that way, but then when I'm pushing on it, I want it to go as far as that point, and I want it to stop there. Okay? I'd like you to come up with a solution for how we can do it. So maybe you can sort of do a little sketch for me, or explain it in words. I don't mind. Do you understand the challenge? Okay, right? So you need to come up with some kind of idea which would allow this to happen. Is that okay? Right? So I want everybody to give a bit of time. So I'm going to stop the video at this point, and then we're going to kind of discuss your ideas at the beginning of the next video. Is that okay? So those of you who are watching on the video, I want you also to have a go. So you can see what the issue is at the moment, and I want you to come up with a little DIY solution of how we would, go about stopping these cusps, these flaps sort of going above 90-degree angle.